Welcome to the Deep Dive. Today we're getting into something fascinating, maybe even a bit paradoxical about AI.
Yeah, it's the strange situation, isn't it?
Totally. Billions are being poured into generative AI. I mean, something like 8 out of 10 companies are already using it.
Huge adoption rates.
Exactly. But, and here's the kicker, over 80% are saying they're seeing no real business value, no impact on the bottom line.
Mm-hmm. Zero tangible contribution to earnings for the vast majority. It's a huge gap.
It really is. And it's not like the tech isn't good, right? These models are incredibly powerful now.
Oh, absolutely. More capable than ever before. Summarization, coding, reasoning. They can do amazing things. The technology itself isn't the weak link here.
So what gives?
Well, what's interesting is that this Gen AI paradox, that people are starting to call it, isn't entirely new. It kind of echoes what we saw with older machine learning projects.
You mean the high failure rates?
Exactly. Remember those stats? Something like 85, maybe even 90% of traditional ML projects historically just didn't deliver the promised value.
Wow, okay, so history repeating itself, maybe.
In a way, it really hammers home that the problem isn't the algorithm or the computing power. It's a failure in, well, strategy. A big strategic disconnect.
Okay, I see. So if the tech is there, but the value isn't, what's that missing link? How do we connect that powerful AI to actual business results? Is it about a different kind of skill set?
That's really the core question.
Right. So our mission today is to unpack this paradox, figure out why it's happening, and more importantly, lay out a kind of blueprint for how organizations and, how you listening can actually bridge that gap.
Yeah, how to make it work in the real world.
We want to demystify what a real AI strategy looks like, how to make these projects deliver measurable value, and how you can become the kind of leader who turns all this AI promise into, well, reality.
Let's get into it.
Okay, so we've established this Gen AI paradox, this Grand Canyon between the money going in and the value coming out, like having a Ferrari engine sitting on the shelf.
Exactly. It's powerful, but it's not actually moving anything forward. And again, the tech itself, incredible. The failure is how it's being applied, or rather, how it's not being strategically integrated.
Which brings us to this idea of the strategist developer.
Mm-hmm.
It sounds like more than just coding skills. It's about bridging tech and business value.
Precisely. It's about understanding that getting AI right is fundamentally a business and leadership challenge first. The tech comes second.
Okay.
This strategist developer role, it's someone who sees the big picture, the organizational impact, not just the algorithm, which, begs the question, what is an AI strategy, really?
Right. It can't just be a shopping list of cool AI tools.
Definitely not. It's a formal, thought-through plan. It has to tightly link AI capabilities to broader business goals. The aim, create real, tangible value.
And it serves two purposes, you said.
Yeah, it's your roadmap showing where you're headed. But it's also, crucially, a risk mitigation plan. It helps you spot and tackle those common failure points before you pour tons of resources down the drain.
Like debugging the business plan before you debug the code. Makes sense. So what are the must-have parts of this strategy?
Okay, first up, and you really can't skip this, vision and business alignment. This is your North Star.
Got it.
If you don't start with a clear business goal, not just an AI goal, but a business goal, you're lost. Your AI project becomes, well, that Ferrari engine on the shelf again. An expensive experiment going nowhere.
So every project needs a clear link to something measurable, like sales increase or cost reduction.
Every single one. Tie it directly to a metric. Boost efficiency by X%. Develop Y new product feature that customers want. Otherwise, you're just contributing to that paradox we talked about.
Okay, clear alignment. What's next? You can have the best strategy, but AI needs fuel, right? Data.
Absolutely. Which brings us to the data management foundation. Data is the lifeblood. You need a solid plan for governance, quality, security, accessibility.
And bad data sinks projects.
It's a classic failure mode. You hear it all the time. Garbage in, garbage out. Even the smartest AI model will fail if it's fed messy, biased, or just plain wrong data. So clean, relevant, secure data is non-negotiable.
Makes sense. Then you actually need the machinery to run it all.
Right. Technology and infrastructure. You need a clear plan here. Do you have the right hardware, like GPUs? What software, platforms, cloud versus on-prem? These choices impact feasibility, costs, scalability, everything.
Okay. And strategy, data, tech. What are the people?
Can't forget the people, talent, and organization. Your strategy needs to cover how you'll assess your current skills, figure out the gaps, and then fill them. That might mean hiring, upskilling your current team, or bringing in partners.
And fostering the right culture, too.
Critically important, a culture of continuous learning because this field changes so fast.
And the last piece, something that feels more important every day. Ethics and governance.
AI governance and ethics,
Yeah.
absolutely non-negotiable. This isn't a checkbox exercise at the end. It has to be baked in from the start.
So thinking about fairness, transparency, accountability.
All of it. Build that framework early to build trust, manage risks, and make sure you're using AI responsibly. It's foundational.
Okay, so that's the strategic blueprint, the big picture. But knowing where to apply AI for the biggest impact, that feels tricky. How do you find those high-value opportunities and, crucially, prove they're actually working?
Yeah, that's where the rubber meets the road. You need a good process for identifying and prioritizing use cases. One really effective way is to go bottom up.
Meaning,
Talk to the teams doing the actual work. Ask them, where are the bottlenecks? What's repetitive and time-consuming? Where do you struggle with complexity or ambiguity? This grounds your AI efforts in solving real day-to-day problems.
I like that. Takes it out of the theoretical and into the practical. So you gather all these potential ideas. How do you sift through them? Find the gold nuggets.
That's where prioritization frameworks are key. A simple but effective one is the value versus effort matrix.
The classic 2x2 grid.
Exactly. Plot initiatives based on potential business value versus the effort needed. You're looking for those quick wins, high value, low effort to build momentum.
Get some early successes on the board.
Right. Then you identify the big projects, high value, high effort, which become your strategic bets. And importantly, it helps you spot the fill-ins and the time wasters to avoid.
It keeps you focused.
Yeah.
There was another one mentioned, BXT, Business Experience Technology. Sounds more quantitative.
It is. The BXT framework looks at three things. Is it viable for the business, financially speaking? Is the user experience good? Do people actually want it? And is it technically feasible? Can we actually build this thing?
So you score each dimension.
Yeah, and combine the scores for a more data-driven ranking. And here's a fascinating stat. The top companies, they focus. They have fewer use cases on average, like 3.5 compared to over 6 for others.
Oh.
And that focus translates. They see something like 2.1 times greater ROI.
2.1 times. That's huge. It really shows the power of not spreading yourself too thin. Okay, so you've picked your battles. How do you know if you're winning? Measuring success. Because a technically perfect model means nothing if the business doesn't benefit.
Absolutely. That's why defining success with KPIs is so critical. You need that unbroken line of sight from the model's performance right up to the business outcome. We use a KPI hierarchy for this.
Okay, break that down. What's at the base?
At the bottom, you've got your model performance metrics. These are the technical ones. Accuracy, precision, recall, latency, stuff data scientists track closely. Is the model technically doing its job?
Got it. Step up from there.
Next level is operational efficiency metrics. How is the AI impacting actual business processes? Things like reduced processing time, lower error rates, cost savings from automation. This shows the tangible effect on how work gets done.
And the top level. Stuff the execs want to see.
That's business outcome metrics. High-level stuff. Revenue growth, customer satisfaction scores, market share gains, customer retention. This shows the ultimate strategic contribution.
So you work backward. Start with the business outcome you want, figure out the operational changes needed, and then define the model performance required.
Exactly. You connect the dots from top to bottom.
And this idea of smart KPIs, using AI on the KPIs.
Yeah, this is pretty cool. Descriptive KPIs use AI to tell you what happened and maybe why. Predictive KPIs forecast what will happen, and prescriptive KPIs suggest what you should do. Companies actually using AI this way on their KPIs, they're 3 times more likely to see bigger financial benefits.
3 times. Okay, strategy, metrics. But who builds this? It's not one person in a dark room, right? The sources emphasize it's a team effort.
Definitely a team sport. They call it the human stack. Like a software stack, different layers, different roles, all working together. You need a cross-functional team.
Okay, let's unpack the layers. Who's the API gateway? Sounds like the interface.
That's your product manager. They're crucial. They translate the business need into requirements, define the vision, prioritize what gets built.
Yeah.
The bridge between business and tech.
Makes sense. Then the core AI part, the modeling engine.
That's the data scientist. Exploring data, building and testing the models, making sure the algorithms work. They're crafting the AI's intelligence.
And getting the data ready for them. The ETL pipeline.
Your data engineer. They build and maintain those vital data pipelines. Cleaning data, making it accessible, formatting it correctly. They keep the high-quality fuel flowing.
Then taking the water from the lab to the real world. CI/CD, and infrastructure.
That's the ML engineer or MLOps engineer. They're the ones who operationalize the models, building automated pipelines for testing, training, deploying, monitoring. They make it robust and scalable.
Turning the science experiment into a reliable product.
Exactly.
And connecting the AI's output to the actual user, the application layer.
Your developer or software engineer. They integrate the model's insights into apps, dashboards, whatever the user interacts with. They make the AI useful.
And overseeing the rules and safety, governance and security.
The AI ethics, compliance, or legal advisor, absolutely essential. They ensure you're following ethical guidelines, regulations, managing bias, privacy, security risks right from the start, the guardians of responsibility.
Okay, that's quite a team. Managing all those different experts must have its own challenges, right?
Mm-hmm.
How do you debug the human stack?
Yeah, it does. It requires deliberate leadership. First, you need clear, shared goals. Use something like SMART goals so everyone's aligned and knows what success looks like for the whole team.
Alignment is key. Communication across those different disciplines must be tricky.
Vital. Set up a communication cadence and tool set. Daily stand-ups, maybe retrospectives, shared platforms like Slack or Jira. Keep information flowing and misunderstandings low.
And creating a space where people feel safe to speak up, especially with new tech.
That's psychological safety, hugely important for innovation. People need to feel okay asking questions, challenging assumptions, even admitting mistakes without fear. That's how you learn and improve, especially with something as complex as AI.
Makes total sense. And clarifying who does what. Accountability.
Yeah, a RACI framework helps immensely. Responsible, accountable, consulted, informed. Define roles clearly for key tasks. It cuts down on confusion and conflict.
Got it. So managing the team is one thing, but the leader also needs to talk to people outside the team, right? This idea of being a stakeholder communication API, what's that about?
It means being a translator. Taking all that technical complexity and turning it into a story that business leaders, non-technical folks can understand and get excited about. If they don't get it or trust it, even the best model goes nowhere.
So how do you become a good translator? Any tips?
First, know your audience. A CFO cares about different things than the head of sales or legal. Tailor your message.
Speak their language?
Exactly. Second, speak in terms of results, not process. Don't geek out on hyperparameters. Tell them, this predicts churn with 90% accuracy, saving us $2 million. Focus on the impact.
Analogies help too, I bet.
Big time. Use analogies and metaphors. An API is like a waiter. A data pipeline is like an assembly line. It makes abstract concepts tangible and leverage visuals. Charts, dashboards, flowcharts often communicate complex ideas much faster than words alone.
Okay. And there was this specific framework mentioned for storytelling.
Yeah, the what, so what, now what framework. It's simple but powerful. What is the key finding? Our model predicts failure 72 hours out. So what is the business implication? This lets us do planned maintenance, not costly emergency repairs. Now, what is the next step? Let's integrate this into alerts to cut downtime by 30%. Clear, concise, actionable.
That's brilliant. Super practical. Okay, so we have the strategy, the team, the communication plan. Now, the nitty-gritty, actually getting these AI models working reliably in the real world. Operationalizing AI. MLOps.
Right. MLOps, machine learning operations, think of it like DevOps, but specifically for the machine learning lifecycle. It's about automating everything to build reliable, production-ready AI systems, taking it from a manual, one-off experiment to a continuous, robust operation.
Let's make that real. Walk us through that predictive maintenance for IoT example for Manufact. How does MLOps work there, step by step?
Okay, so step one, project scoping and design. Manufact's problem is expensive, unexpected machine breakdowns. The team translates this into an ML task. Predict failure within, say, the next 7 days. They set clear objectives and key results, OKRs, maybe 90% prediction accuracy, 25% less downtime, 20% lower maintenance costs. Starts with a business need.
Clear goal. What's next in the MLOps flow?
Step two, data ingestion and validation. Data engineers set up pipelines to pull in real-time sensor data and historical maintenance logs. Critically, they implement automated data validation checks using tools like Pandera or TFDV.
Why is that automation so important?
It catches data quality issues, weird values, missing fields, schema changes before they poison the model. It's like an automated quality check ensuring only good data gets through. Garbage in, garbage out prevention.
Got it. Clean data flowing in. Then the data scientists step up.
Step three, feature engineering and experimentation. They take the raw data and create useful features, things like rolling temperature averages or time since the last oil change. And every experiment features tried, models tested, parameters tuned, gets tracked meticulously. Tools like MLflow or weights and biases are used here.
For reproducibility.
Exactly. So you always know how a specific model was built and can recreate it. No more magic models that nobody understands.
And the actual training.
Step 4, model training and validation. They train different models, but validation isn't just one accuracy number. They check performance across different machine types, different factories to ensure it works fairly and robustly everywhere. And they use explainable AI tools like Shape-A or Lime to understand why the model predicts failure, builds trust.
Making the black box less black.
Precise.
Now, taking it from the lab to live production, this is where CI/CD comes in. Sounds like heavy automation.
It is. Step 5. CI/CD for ML automated deployment. The ML engineer builds automated pipelines. Continuous integration, CI, automatically tests new code and data validation steps. Continuous training, CT, automatically retrains the model on new data when needed. Continuous deployment, CD packages, and safely deploys the updated model, maybe using canary releases to test it on a small subset first.
Automating the whole release process.
Right, making it faster, safer, and more reliable.
And it's not done once it's deployed, is it? The world changes.
Definitely not. Step 6. Production monitoring and automated retraining. You need constant monitoring in production. Tools like Evidently AI or Fiddler track things like data drift is the incoming data changing, and concept drift is the relationship between inputs and outputs changing, making the model less accurate.
Like the model's understanding becoming outdated.
Exactly. It also monitors operational stuff like speed and throughput. If significant drift or performance decay is detected, it can automatically trigger a retraining pipeline, deploy the new model, and close the loop. Keeps the AI accurate over time.
That's a really robust, continuous cycle. But beyond just making it work, there's the trust element we keep coming back to. Responsible AI, or RAI. How does that fit into MLOps and the whole lifecycle?
RAI isn't a separate step. It's woven through everything we just discussed. It's foundational. It's about proactively building fairness, transparency, and accountability into the system to manage risks and build that crucial trust.
Okay, so what are the core principles we need to keep in mind for RAI?
First, fairness and bias mitigation. Actively looking for and addressing biases in data and models. This means diverse data, using bias detection tools, and checking performance across different groups. A model that works well overall but badly for one group isn't fair.
Makes sense. Preventing discriminatory outcomes.
Yeah.
What else?
Accountability and transparency. Who owns the model's outcomes? Having clear roles, like with RACI, helps. Meticulous documentation is key. And using explainable AI, XAI, so you can understand why the model makes certain predictions. It's vital for debugging, trust, and often for regulations.
Showing your work, essentially.
Exactly. And finally, security and privacy. AI introduces new risks. You need strong data governance for privacy rules like GDPR, and you need to actively protect models from attacks designed to trick them or steal data.
Okay, so bringing this all together, for you, the listener, maybe a developer wanting to move into this space, how do you make that leap from focusing purely on code to becoming this AI strategist, this leader we've been talking about? What's the path?
It's a mindset shift as much as a skill shift. First, think beyond the model. Realize AI success isn't just about the coolest algorithm. It's about solving a real business problem and delivering value. Link everything back to the strategy.
See the bigger picture. And getting good at working with that diverse team.
Yeah.
Mastering the human stack.
Absolutely. Develop those cross-functional leadership skills, setting shared goals, communicating clearly, fostering that psychological safety, using tools like RCI. It's about orchestrating the team effectively.
And becoming that stakeholder communication API, that translation skill.
Crucial. Learn to translate tech talk into business impact. Know your audience. Focus on results. Use analogies. Visualize data. Practice that what so what now what storytelling. Gain buy-in.
And given how fast AI moves, you can't stand still.
Never. Commit to continuous learning. It's non-negotiable. Take courses, get certifications, yes, but also read widely. Follow thought leaders. Read publications like MIT Sloan Management Review, HBR, McKinsey Insights, practitioner blog. Stay curious.
So wrapping up our deep dive, we've explored the Gen AI paradox, the need for a solid strategic blueprint, building and leading the human stack, the power of MLOps for operationalizing AI, and the absolute necessity of responsible AI principles. The big takeaway, success really hinges on bridging that gap between the technical and the strategic.
And looking ahead, it gets even more interesting. The trajectory isn't just better models, it's moving towards agentic AI. Think complex, proactive systems that don't just respond, but can actually take initiative, automate entire workflows. The potential value is astronomical, potentially trillions.
Wow. Agentic AI. But here's the final thought, maybe the most important one. The biggest hurdle to harnessing that future, it probably isn't the technology.
It's human.
It's a challenge of leadership, of strategy, of building trust. And that's the huge opportunity for you listening right now. If you're ready to look beyond just the code, you can become an architect of this future, designing not just the models, but the strategies, the teams, the ethical frameworks that will make this powerful technology truly successful and beneficial.